Okay, basic antiderivatives, trigonometric. Okay, so first off, what I need to do is apply a rule that's true for limits or derivatives, which is move the constant outside the integral. So I get integral 2 sine of x dx, okay? And that's a rule that's true because of integrals or antiderivatives being a limiting process. The integral of c times f of x dx is equal to c times the integral of f of x dx. So then what I can do is take the antiderivative. So the antiderivative of sine is negative cosine, and I get the plus c, which is my constant of integration. And if I want to check that, so my check, I can take the derivative of negative 2 cosine of x plus c, and I get, let's see, derivative of cosine is negative sine, so I cancel the negatives, so I get 2 sine of x. And the derivative of constant is 0, so I just get 2 sine of x. So it works. And let's look at this one. Integral of cosecant x cotangent x. Well, by rule, that's just negative cosecant of x plus c. And again, you need that constant integration plus c. Most teachers, most college professors I've seen would mark it wrong if you left it off on basic antiderivatives. So, how would I check that if I wanted to check it? Well, the derivative of negative cosecant of x plus a constant c is equal to, well, let's see, cosecant is negative cosecant x cotangent x, but then I have a negative out front, so those cancel out. Derivative constant 0, so it works. And again, I'd recommend knowing your tables and being able to take derivatives in your head to be able to check your work. Alright, 2 more examples. So this one, there's no rule for number 3, integral of sine of x cosine squared x. So let's see, how can I rewrite that doing some algebra or trigonometry? So I have sine of x and I have 2 cosines, so I can make it cosine of x times 1 over cosine of x dx. Alright, and then cosine times cosine is cosine squared, so I'm good. And then sine over cosine is tangent, and 1 over cosine is secant x. So I have a rule for antiderivative of secant tangent, so I could always rewrite that in a different order if it helps me recognize it, and I get secant x plus a constant of integration c. Okay, and I could mentally check that by going the derivative of secant is secant tangent. Okay, so I'm good. Alright, number 4. I don't have a rule for that one either, but I recognize by my trig identities that that's secant squared of x dx. And again, you gotta know your trig IDs, okay? And the integral of secant squared x dx by rule is tangent of x plus c. And again, I could check that derivative of tangent is secant squared, which is 1 over cosine squared, so I'm good.